Some of the key points that we need to look at when we are talking about our converged network is that it has a collaboration as its requirement. We have to be able to do more with more objects, more devices, more types of devices, more types of data at the same time. And to support this collaboration, networks have to employ what's called converged solutions, where they take different things such as our IP phones, our email, our webcam, and pull it all into one device. That way, data services, like I said, such as the voice systems, IP phones, voice gateways, video support, and video conferencing work together, as well as call control, voice messaging. The mobility and automated attendance are also common features. And some of the benefits of this converged network include multiple types of traffic. Only one network has to be managed at a time, and sustainable savings over installation and management of separate voice and video and data networks. And it integrates our IT management. We have to have less people to cover more devices and more services. As you're going through the ebook, make sure you take time to watch the video. It is the second screen. When you get to 1.1.2, the converged networks. The first one has the image I used in the PowerPoint. And then this next video here is a real good example of converged systems that use the different types of communications that we talked about. Next, let's talk a little bit about our borderless switch networks. The Cisco Borderless Network is a network architecture that allows organizations to connect anyone, anywhere, anytime, on any device securely, reliably, and seamlessly. Gone are the days where everyone that works for a business is housed in the exact same location. You have people who travel for work, they need to be able to connect. You may have people who work from home, they need to be able to connect. So this borderless network is ideal for this type of situation. It is designed to address the IT and business challenges, such as supporting the converged network in the changing work patterns. You never know, you may start out with a very small business that you think will always be housed in one location. However, your business may grow and you may need to be able to have that borderless setup so that the people who work for you can be at different locations or can travel. So the borderless network comes in to play at this point. Another video that you need to take a close look at is here the evolution of borderless networks. It talks to you a little bit about what the borderless network is. It's going to explain it. It's just a real quick 2.5 minute video, so that's a great one for you to look at. Now, with the borderless switch network, we do need to look at the hierarchy of it, and it's built on several things. You have a hierarchical structure, you have modularity, resiliency, and flexibility. Hierarchical just means that the facilitates the understanding the role of each device at every tier, and it simplifies deployment, operation, and management, and reduces fault domains at every tier. Now, as far as modularity is concerned, that allows a seamless network expansion and integrated service enablement on an on-demand basis. So as each module needs to come online or become part of the network, it can. The resiliency satisfies users' expectations for keeping your network always on. It's rather frustrating when you need to be on the network and something is down. We're so used to everything being right there all the time. And then we also have flexibility, and that allows for an intelligent traffic load sharing by using all network resources. You get really frustrated when it's slow. So this is where the flexibility comes in. Now these come into play together. They're not separate principles, but they're dependent on each other. Another thing that we need to look at is that there are 3 critical layers within the tier design, And those are our access layer, our distribution layer, and our core layer. And each layer can be seen as a well-defined structured module with specific roles and functions in a campus network or a large network. And introducing modularity into the campus hierarchy design further ensures that the campus network remains resilient and flexible. Here's an example of the three-tier design. We have our access, our distribution, and our core. We may only use a two-tier LAN design in a small or medium-sized business that doesn't need to have all three and have the resources available. You may end up having a collapsed core and distribution layer that work together. We have our access layers, our distribution, and our core. And you'll notice here this converged network has different buildings with different needs, but they all have their access, their distribution, and their core layers. With the access layer, it represents the network edge. It's where traffic enters or exits the campus network. Traditionally, it was the primary function of the access layer switch to provide network access to the user. And the access layer switch connects the distribution layer switches, which implement network functions and foundation technologies such as routing, quality of service, and security. The newer switches, or the next generation switches platforms, now offer more converged, integrated, and intelligent services at various types of endpoints on a network edge, depending on the size of your network again. Next, we have our distribution layer, and the distribution layer interfaces between the access layer and the core layer. It's kind of the middleman. It's aggregating large-scale wiring closet networks. We have aggregating layer 2 broadcast domains and layer 3 routing boundaries. It's providing intelligent switching, routing, and network access policy functions to access the rest of the network. Also, it's providing high availability through redundant distribution layer switches to the end user and equal cost path to the core. It's kind of monitoring that network traffic and trying to keep everybody happy. It's providing differentiated services to various classes of service applications at the edge of the network. And then finally, we have our core layer, and it's the backbone of our network. It connects several different layers of the campus together, and the core layer serves as the aggregator for all the other campus blocks and ties the campus together with the rest of the network. So it's our backbone. It kind of holds everything up like your backbone holds you up, and everything is kind of connected to that. So here we have a three-tier design. This would be your two-tier design where your core and your distribution are collapsed together. Take the time to do this activity. It is not graded, but it does let you know whether or not you understand the concepts that have been covered so far in this section. Now, the role of our switch networks have changed and evolved over time. The switch LAN allows for more flexibility, more traffic management. It also supports features such as quality of service, additional security. It supports for wireless connectivity, support for IP telephony or your IP phones, and the mobility services. So this growing switch network that has learned how to be converged is benefiting us in many ways. There are different types of switch networks. This is an example of a fixed switch, and the features and options are limited to those that originally come on the switch itself. Here we have a modular form factor, and the chassis accepts line cards that contain the ports or more ports as you need them. These cards, if you've ever worked with a PC where you're adding your expansion cards into the expansion slots, that's basically how these additional ports work is they plug into the chassis. Depending on what size chassis you have, is determines how many more line cards you can add. And finally, we have our stackable form factor. The stackable switches are connected by a special cable, and they effectively operate as one large switch. But you do have to have these special cables in order to connect them so that they see themselves as one large switch. You're, in essence, doing a daisy chain to connect them. You'll see that these two are connected, and then they work their way up in their connectivity. So it sees it as one large switch.